So when we make measurements, we know that the measurement is going to have three components, or how we report it. We know that we have the number, we have the unit, and then we have how well we know the number. How well we know the number is referred to as the number of significant figures in that number, which we're going to call sig figs for short. So we need to know how to read a measurement to get the number of significant figures. And so let's say that we have some sort of a device for making measurements. So if we've got a graduated cylinder for making measurements, it's going to have marks on it. And we're going to be able to take and read the marks. Now, the rule for reporting sig figs, which means making a measurement and giving your answer to the correct number of digits with reasonable certainty, is you report every digit you're certain of. So reporting sig figs, every digit you are sure of, and then the first estimated. So every digit you're sure of and the first estimated are going to be the number of significant figures in that measurement that you have just made. So you're going to take anything with a scale is going to be what you're going to take and use sig figs on. You're going to take the digit, and you're going to estimate the digit by figuring out how much or how many spaces are in between the last set of markings on the scale. So let's take a look at that. So if we take a ruler and we look at these, we know these two values very differently. If we look at this one, we know for sure that our measurement, if we're right here, is greater than 2 and less than 3, and it's going to be greater than 2.12345. So we're going to have 2.5, and we're sure of that. And then we're going to estimate the next value and say that's about 0.5, and we're going to say that this is about 2.55. Right? We're pretty good with that one. We're certain of the first, the first five, and we've estimated this one. Now here, all we know is that it's in between 2 and it's less than 3, and so we're going to say that this one is about 2.5. Because it doesn't have the extra tick marks, we cannot report the measurement to as many sig figs or as much certainty. So again, reporting sig figs. Every digit you're sure of, and the first one you estimate. So when we have volume, we're going to read from the bottom of the meniscus. If we look at this value, we know it starts at 20. We know it's greater than 20. We have to figure out what each of these tick marks mean. If we look at the value between 20 and 25, we realize that each one of these corresponds to 1. So we have 21 plus something. When we're going to estimate that, you're going to have to figure out what that looks like to you. That looks like about a 0.6 to me. And the volume on this is 21.6. This would be milliliters. We know that because it's got mLs up there. So 21.6 milliliters is the volume in this graduated cylinder. When you report the volume or any measurement, every digit you're certain of, and the first only estimated. So if we looked at this one instead, this becomes much more difficult. We know it's greater than 100 and less than 200. So if we want to estimate that one, we might call that 170. If we're here between 19 and 20, we've got to estimate this one up. We're going to have to, again, 19 point something, and you're going to have to figure out what that looks like to you. That looks like closer to a 8 than to a 9 to me, and I'm going to put 19.8 degrees Celsius. The more tick marks it has on it, the more significant figures you're going to be able to get out of the measurement. All right, quick note on accuracy versus precision. Accurate is how close it comes to the actual value on a quantity. So, accurate, meaning here, it's close to the correct value. Now, precise. Precise here is how close they are to one another, which means how reproducible it is. This is precise. They're all closely grouped. This one, in fact, is accurate and precise because it is close to the correct value and they're all nicely grouped. This one is neither accurate nor precise as they are not closely grouped and they are not close to the correct value. We are looking for both. We are looking for both close to the correct value and reproducible. So, significant figures. We know that significant figures are all the digits that are part of the measurement. This indicates your level of uncertainty. Please realize that 2 centimeters is not the same as 2.00 centimeters. The more significant digits we have, the more precise the instrument that we use to make the measurement is. So what kind of numbers have sig figs? Well, the only kind of numbers that have sig figs or significant figures are measured numbers. We have to have some sort of an instrument. If we have an instrument, we have a measurement. If we have a measurement, we have uncertainty. It's different than counting numbers. For example, 15 dogs or 3 pills. These are counting numbers. There is no error in this. For example, if I say that underneath my desk at the moment I have 1 dog, if this is not approximately 1 dog or 1.00 dogs. This is 1 dog and it is exact. If we have an exact number, anytime we have a counting number or a defined number, it has an infinite number of sig figs. All the metric prefixes are defined and they are exact. And there's other conversions which are also exact. For example, 12 inches are exactly in 1 foot. You will be told if they're exact. Otherwise, look at counting numbers. Counting numbers are always exact with an infinite number of sig figs. So let's classify these as exact or measured. Gold melts at this temperature. Well, you need a thermometer, therefore it's measured. 1 yard is 3 feet. Well, we tend to put 3 lines on that, and that means exactly. It's a definition, and this one is exact. You would be told that the diameter of a red blood cell is about this. Well, it's a centimeter, it's a measurement, and that is going to be M. Not exact. 6 hats, counting number, exact. Can of soda has this number of mils. Well, that's a measurement, therefore M. 12 cats, too many cats. That's exact. All right, significant figures. We are going to look at the number of sig figs or how well we know a number. If we have 1 digit that we report, we say it has 1 sig fig. If we have 3 digits that we report, we're going to have 3 sig figs. The last one is always estimated, so if you only have 1 sig fig, it is inherently estimated. If you have 3 sig figs, the first 2 are certain, and the last one is estimated. The last digit will always be an estimated or uncertain digit. So, rules for sig figs. The best way to look at sig figs is to realize that placeholders, which just keep track of how big or how small the number is, are not significant. So, when we have a measured number, the significant figures are all the digits that we have, including the measured number. So all we need to consider are numbers with and numbers without a decimal. If the number has a decimal, the rule is all the digits to the right of the first non-zero value count. So if I have 0.00155, I have a decimal, I go to the first non-zero digit, and then I count to the right, and I have 3 significant figures. If instead I have 150.50, and I look at this, I have a decimal, I go to the first non-zero digit, I count right, and I have 5 sig figs. So with a digit, we're going to go to the right. With no digit, we go to the left. So if I have 1200 and I have no decimal, I go to the first non-zero digit and I count left. I have 2 values, including that 2, so this one has 2 sig figs. And that is how we figure out sig figs. Again, if it's has a decimal, we go to the first non-zero digit and we count to the right. If we have no decimal, we go to the first non-zero digit and count to the left. To make our lives easier, we frequently use scientific notation. And when we do this, if we're careful, it kind of keeps track of how many sig figs we have. So if we have 5,000 with a decimal, this number is going to have 4 sig figs. How do we know this? We go find the decimal, go to the first non-zero digit, and everything to that counts. And so when we write it in scientific notation, we need to include all the zeros that count. and we would do it like that. If we had 5,000 without a decimal, we know that we go here, we count to the left, of which there are no further digits. We're just going to do 5 times 10 to the third. The number of zeros tells us how well we know our value. So let's count sig figs. All right, this one has no decimal, so we start here, we go left, we have 3. We go this one here, we have a decimal, so we go here, go to the right, we have 2. Decimal, go to the first non-zero digit, go to the right, and you have 3. This one has a decimal, go to the first non-zero digit, go to the right, and you have 4 sig figs. Now, when we get to our calculator, we're going to have problems because our calculators just take stuff out to about 7 or 8 or 11 or 12 digits, and frequently we don't know our number that well. So we're going to have to take them, we're going to have to round. So let's do a quick set of rules on rounding. We're not going to worry about the serious precision here. We're going to say if the last digit that we keep is going to be, the last digit we keep is 5 or greater, we round up. If the last digit we keep is 5 or less, we round down. So if we take this value right here and we round to 3 sig figs, we're going to drop a 4.12. So if we're going to remove anything that's less than or equal to 4, we round down. And when we round down, we remove the excess digits, giving us this. If the last digit that we keep is 5 or greater, so if we're going to remove anything that is greater than or equal to 5, we round up. When we round up, we add 1 to the last digit we keep, giving us 652. We want to round this to 3 sig figs. We're going to remove here the 7. The 7 is greater than or equal to 5, so we're going to add 1 here. When we add 1 here, we're going to get 20.0. That's 3 sig figs, and we're right there. All right, sig figs and rounding. So let's consider this one, multiplication and division. We're going to have 2 different rules, one for multiplication and division and one for addition and subtraction. Multiplication and division is by far the simplest, and it simply tells you that your answer has the same number of sig figs as the measurement with the fewest. So if we take a look at this, we are driving 167 miles in a period of 3 hours. We want to know what the speed is in miles per hour. When we do our math here, we're going to get 55.7 miles per hour. We have 55.7 miles per hour. We got to look at our sig figs. Well, we have 3 sig figs here and we have 1 here. If we have 3 sig figs on the top and 1 on the bottom, it means our answer can only have 1 sig fig because we're going to round up or round so that the answer has the same number of sig figs as the measurement with the fewest. Fewest is 1. And if we're going to take and remove these values, 5 is greater than or equal to 5. And so we're going to add 1 here. When we add 1 here, we're not going to get 6 miles per hour. We're going to have to keep track of our placeholders, and we are going to get 60. We don't put a decimal in because that would give us an extra sig fig, and our answer is simply 60 miles per hour. And because we don't know this value very well, we don't know that one very well either. All right, so if we take and we multiply 1.9 times 0.087 times 12.1, we're going to get a total of 2.00, and it keeps going. Our units are going to multiply together, and we're going to get centimeters cubed. We're going to look at our sig figs. Our smallest here has 2 sig figs, and so we are going to round this to 2.0 centimeters cubed. If we take 1.1 and we divide it by 2.874 times 10 to the minus 6. Make sure that you either know how to put 10 to the minus 6 in your calculator using the EE or the EXP key, If you don't and you use the little caret key, make sure you put that in parentheses, otherwise you're going to lose the 10 to the minus 6. When you're finished with the math here and you look at your sig figs, you need 2, and you're going to get 3.8 times 10 to the 5th. If I take 4.311 and I divide by 0.07 and I look at my sig figs, this one has 4. This as a decimal, I go to the first non-zero digit, so it's got 1, and I'm going to get an answer here of 61.58, rounded to 1 sig fig, meaning I have to drop all of this, is going to be 60. Don't lose the placeholder on that one. All right, the pain is not multiplication and division, it is addition and subtraction. Addition and subtraction, the answer is going to be rounded to the same decimal place as the quantity with the fewest decimal places. What do we mean by that? If I take 25.2 and I add to 1.34 and I look at my decimal places, it says 1 decimal place. This one has 2 decimal places, so I'm going to round this to 1. I'm going to get this one. If I take here and I subtract this and I take 0.273 and I subtract 0.253 and I do my math, I'm going to get 0.020. I know this value to the 3rd decimal, and so same with this one. So my answer is to the same 3rd decimal. Now note, when I do this, I have actually lost sig figs. We can gain and lose sig figs when we do addition and subtraction. We have troubles when our numbers, in a sense, don't overlap. If I take 1210 and I add 73 to it, I do not know this value's ones place. I only know it to the tenths. So when I add here and I get 1283, because I don't know the ones place in this one, I can't know it here, and my value is 1280. Those are the hard ones. One way of doing these is if I take 1.1 times 10 squared and I add it to 1.23 times 10 cubed, I can take and put these so they have the same exponent. If they have the same exponent, then the coefficients are simply going to add. So if I take my 1.1 times 10 squared and convert it to 10 cubed, shift the decimal place 1 over, and I add them up, I'm going to get this 1.34, 2 digits past the decimal, because I've got 2 digits past the decimal here. All right, so I've got 2 volumes here. I have 180 mils. In my 180 mils, I know the tens place and I know the hundreds place, but I don't know the ones place. This is an unknown, and that is an estimated digit. And let's say I add this to 10.62 milliliters, and when I add this up, I can do the math, and I get 190.62 milliliters, sort of implying that I know this value to 5 sig figs. Well, there's a problem. And the problem is that I don't know this one. I do not know the ones place in the 180, which means I don't know it here, which means I certainly don't know those two either. So we are very tempted to just add it up mathematically, but we have to be very careful with what we know. And because we do not know the ones place in the value here, we can't include it in our final answer. And our answer is, in fact, 190 mils with 2 sig figs. Now, sometimes we are going to have to use both rules, which means we're going to have rounding and we're going to have to be careful. So, for example, if I take 1.29 times 5.1 and I look at this, I'm going to get 6.579. If I take and I add that to 6.05, I am tempted to use that as an answer, but let's be careful. 1.29 times 5.1 is going to give us 2 sig figs right here. When I look at this, I'm going to have 6.579. Now, the rule here is we are going to wait until the end until we round. So if we do that and we take our 6.579 and we add it to 6.05, and we're going to get 12.629, we know we're going to remove the 9. That's a minimum, but then we take a look back again and realize we actually have to stop right here at the 6, because this value we only know to the tenths place, And so we're going to stop this one here at 12.6 to 3 sig figs. Why? Because this value only has 2 sig figs, and when we do addition and subtraction, we only know it to 1 past the decimal. What do we mean by that? Let's try the next one. If we take 0.829 and we subtract 0.815, we're going to get a value of 0.014. Now note we've lost sig figs. When we lose our sig figs, we're going to change what we know for the next value. 0.014 divided by 0.829 is going to give us a total of 0.0169, but we only know this one to 2 sig figs, meaning we only know this one to 2 sig figs, so our answer is 0.017. Do the math, round at the end. So if we take 66.8 and we divide it by 2.045, we are going to get 32.665. If we add that to 0.323, we are going to get 32.988. And you ask ourselves, great, now what do we do with this one? Well, if we have 66.8 divided by 2.045, that's 3 sig figs. Well, if we have 3 sig figs, it tells us that we have to stop our number right there, because this is only going to know it to 3 sig figs. So we're going to lose a few on this one. When we take and lose a few, and we're going to lose them right here, and we remove those digits, this is greater than 5, so we're going to have to add 1. And so as we add 1 here, our 9 is going to go to 0. Our final answer is going to be 33.0. Multiplication and division aren't bad. Addition and subtraction is a pain.